Hello everybody, my name is Raphaël Delhomme. I work at Oslandia, which is a small French company specialized in GIS application and open source tools. So I will present a work about back sharing station analysis. This work has been done by Damien Garot, which is one of my colleagues and me. So, to introduce my speech, you certainly know what is a shared bike services. So this picture comes from Lyon in France. So in large cities, you might want to do some little travel within the city, and you might need some transportation mode. So shared bike is a good solution, easy to use, and the great question to answer is: are there available bikes at stations, or if you have a bike, are there available stations to drop off your bike? So that's this kind of question that we try to answer, and we did some analysis by using some machine learning application. So the first question we wanted to answer is the fact that a bike sharing station can be classified in terms of the way users use them. So maybe there are some similar patterns between stations. And we were also focused on the building of a complete data framework, a complete data pipeline from open data. So you can gather some such data on open portals. So from portals to homemade API, for example, and by store data or by apply some treatments, and that's this complete framework we were interested in. So in this presentation, I will present you what is the data we used. Then the part 2 and 3 are some proof of concept of the types of analysis we can handle with such data. And to finish the presentation, I will show you a short API, a little API, that we developed. So just to begin, we talked about geospatial data. We are interested in how bike sharing station works, so we can gather this data on a public portal. So for example, we worked with the data of Lyon and the data of Bordeaux, two French cities. So it could seem a little bit rough, but such data are not so complicated to handle, because we just have some station IDs, some timestamps, and at each timestamp for each station we have a number of available bike station, a number of available bike, and the sum of these two quantities is normally equal to the number of spots of the stations. So we also have some station which doesn't work. So in such an example, we can see that there are no available station and no available bike on the second line. So that means that the station is closed. And in our studies, we just manipulate this kind of data sets of data frame. How we handle this data? So we worked with Python, and to build our data pipeline, we use Luigi, which is a Python library dedicated to data pipeline building. So the fact was to get the data on the portals. So the data was on JSON and JSON formats, on XML formats. We were able to find some shape files too. And the objective was to store this data in base and to apply some treatments, some machine learning treatments to them. So the first application, the first analysis that we did with the data was to classify bike sharing station in terms of their utilization. So we have some stations that are not so well used. We have stations that are very used on the evening, other ones that are very used on the morning, and so on. So we wanted to know how this can work, how a system in a city can work. When I talk about time series, so it's availability bike time series, and we have some example. For example, in green, through one day, we can see a station. So on the beginning of the day, there are a lot of bikes available at the station, and on the evening, it's the opposite. We have so in orange and blue some other example, and this work was inspired from a similar work done for Dublin City by James Lawlor. And the result of such a clustering was this kind of figure. So we have 4 groups of stations. These results are for Lyon, the city of Lyon. And we found one cluster which gather all the stations that are where a lot of bikes are during the day, but not during the night. So that's the blue cluster. There is an opposite cluster in red where a lot of bikes are on the station during the night, but not during the day. So we can see that it means different situation. In blue, it's probably a place where people live or work, sorry. And in red, it's where people live. So they take the bike on the morning and go with the bike where they live. And on the evening, they'll take back the bike and set it in the place they live. In purple, we have another cluster which represents a station where people can go out on the evening, for example, so place near to restaurants or bars and so on. And we can, to make it more clear, we can set all the stations with this clustering representation. So it's the city of Lyon. And I don't know if somebody in the room knows Lyon. So we have I will begin with the purple circle. So the place where we go out on the evening. So it's the city center with all the restaurants and bars and so on. We have the place where we work in blue. So it's the business neighborhood with the main station. We have the universities on the top of the graph, and all the red points. It's mainly a place where people live. So with a lot of residential area. So that's it for the first example of application. Then after that, we tried to predict the availability of bikes at shared bike station. So what we know in such situations, so we know the date, the time of the day, we know how many bikes there are at the station, but the question we want to answer is how many bikes will be there on the station in the next hour. So it means that we will use supervised learning to use the availability the available information to predict a new information, and we can verify our prediction because we have the data So we used the method which is called XGBoost. So I won't enter into the detail of the method, but to be as simple as possible, XGBoost it's a decision tree method. So we use decision trees and gradient method. So the why we want to predict is the availability probability of finding a bike at the next hour, and the information we have, so x variables are the hour, so the time of the day, so in the week, is it a Monday, is it a Tuesday, and so on, and the available bikes at the current hour. So just to show you some picture of the proof of concept, on the top you have the prediction of the model. On the bottom you have the ground truth. So we won't go into the detail, but we can see that even if it's small, the blue points are really similar in the two graphs, and the red points as well. So when it's blue, it means that in 1 hour there will be a lot of bikes at the station, and when it's red, it means that it will be hard to find bikes. So it's a synthetic scale between 0 and 1. And what is interesting, that if we plot the error on the left, you can see that there are not so much stations where the model is not good. So we have just 2 stations maybe on the left, which indicates that the model is not able to predict the good amount of bikes there. So we didn't really work on the features. We didn't try to improve the definition of feature to get a better error indicator, but it could be a possibility to get a better result. So to finish the presentation, I can show you a little demo of our API. So that's on the internet. Click on this link. And this API has been developed with Flask, so it's a REST API. We have the 2 cities, so Bordeaux and Lyon. We can imagine to gather more data from more cities to add them to the API. There is a project on GitHub. I will give you the address at the end. And there is a documentation. So it's not really a documentation, it's more a way to get some data in JSON format. We can try a little demo. So we have one table and we can try to gather some data. So maybe by indicating a date. So we add data so the data was from September or August to September, sorry. We can get three days of data. We can focus on Lyon again. And IDs for the IDs of the bike sharing station. So it's a try. I'm not sure. Yes, well, I don't know the ID of the station by heart, but that's the ID. And if you can so execute the request and get all the data in the JSON format. So maybe I will have another example after, but that's the global ID. With this request tool, we have graphical parts for the API. So we can represent all the stations in Lyon and in Bordeaux. we can zoom and get the station name. For example, this one is Tolstoy Verlaine. We have a list of stations and all the transactions. So there is nothing there. Where is my mouse? So we can also click on the station to have some more information about the station. So for example, this station is Terreau-les-Thermes. So this station is located on the city center. And zoom. We have some information. We have the daily profile. So it's a station where people go on the evening. There are a lot of bikes on the evening. And we have also the daily profile for Monday, Tuesday, and so on. We have some time series for the last day, and we have the last week if we want. And the last transaction. So, for example, we are the 3rd of February. We still get data every 5 or 10 minutes. And so the API is able to represent this recent data. So what I mean by transaction is a transaction is when someone take a bike or drop off a bike to the station. So this is the GitHub project. It's called Jitanshia. I don't know why. Maybe it's Japanese. It's my colleague that give this name. So I was not so confident in my ability to show you the API. I prepared some screenshots. So just this chart, I didn't show you this chart. It's the amount of transaction for the most used station, and we can see that the 2 stations that are the most used are near to the train station, Gare Pardieu. So that's a little indication of how the network is working. And that's it. So in conclusion, I hope I was able to show you that with simple geospatial data we can do some interesting stuff with machine learning. So we tried to build a complete data pipeline with Python and Luigi. We did a little API that if you're interested in, you can complete this API. And our objective is to do online learning. So the little example I show you, so we train an XGBoost method and clustering algorithm for only 1 week of data. With only 1 week of data, one objective could be to train our algorithm online. So with new data, we get better training and have something which is of a good quality, even with newer data. So thank you for your attention. You have the address of the GitHub project there. You can also go to the blog of Auslandia to have some information. There are some blog articles which are talking about this project. And you can also send us email if you're interested. So thank you for your attention. Maybe there are some questions.
You addressed it in the first part of the presentation I made. How are you obtaining the data from the APIs? do you have like some API that is exposed to you?
You are talking about our API or the geospatial open portal?
How you're collecting the data about the bicycle transactions?
So
You're providing that as a service to the city of Lyon?
no, it's a R&D project. It could be an objective.
Okay.
The city of Lyon
its own-
offer the data.
Oh, cool. So the data is
And-
basically free and then you could get it.
Yeah,
from the
exactly.
API.
So we use, you know, it is open geospatial data,
Okay.
and you just have to go on this website
Okay.
and gather the data. So the data are in GeoJSON formats,
Okay.
in
and how
XML format.
often they expose the data? Is it like daily thing? Or?
Yeah. Every 5 minutes or
Cool.
so on. We just build a cron job,
Okay.
which gather
Yeah,
the
that's
data every
very good.
5 minutes and store them into our database.
Okay, cool. Thank you.
Your patterns plot, do you consider the data of just one day, just one week on the business days, or in this case?
This
yeah.
one?
No, this, not the, yeah.
It's a typical day.
It's a typical
Yeah.
business day. Like
Yeah, exactly.
standard day. Okay.
Yeah. We just mix every types of days.
Yes. And these are 4 clusters, and how do you decide that these are 4 not?
Oh, that's our choice of
Okay,
modeler.
you choose 4 clusters.
Yeah.
And the second, final question is, okay, so if you pick up a holiday, you probably get completely different pattern,
Yeah.
right?
Yeah.
Okay.
We show the Lyon results, which is good.
Yes.
The results in Bordeaux, it is not so interesting. So
Okay.
it
You
could
target really
give.
big patterns.
It depends on how the city is organized.
Yes.
Yeah.
Have you tried in Paris? Because
No.
The data is also available for Paris.
Yeah, certainly, but we didn't check.
Yeah.
But it could be interesting to add
Yes.
this.
Okay.
I'm also quite interested about the project. So
Maybe we can continue to ask question. Yeah.
sorry.
But if you want, and after your question, yeah.
I'm just curious about
Okay. So you have a question? I, maybe.
some stations down just provide data for what you have some special alarm system or you have some kind of separate interface or a guide how they can get missing data or do you have some injection in your data?
The question is about missing data.
Yes,
Uh,
just provide data.
We just gather the data. We have a cron job which recover the data every 5 or 10 minutes, and we do not have any alerting tool which say us, oh, warning, there are missing data. We just consider them a posteriori after gathering the data.
So when you make your statistical models, you don't consider the missing data or that's zero at some point on some stations.
I'm not sure about that. It's not me that did this job, but I guess the missing station are dropped from the studio. Just dropped. Yeah. Yeah, of course. I would say that this job could be generalized to everything if you have the same pattern of data, the same data. So it's geospatial data. You have a continuous data gathering process, and it's just that.
The other way around, if you look at how people deal with ATM and their algorithms.
We didn't check the ATM part. We just were focused on bike sharing station because we did some work about transportation how transportation is organized within a city, but with no doubt, it could be possible.
You cooperate with the bike sharing stations or providers to get this on the website, or?
Not yet. We were just at the proof of concept step. One perspective could be to, to give this API or propose the API to the service provider, because I don't know the added value of such a thing. It's a way to reformulate the data, so maybe it could be interesting for us, but the question was not really not yet asked.
As a general comment, I think that it is the perfect case of using a lambda architecture to parallelize this application, because it just brings transaction in respect of the partial part. You can analyze a huge amount of transactions, a lot of channels, a lot of
Yeah.
data, because probably using PostGIS code is really limiting, because you partly would find limitation of speed and capability of analysis for this kind of read-only data. So I would try to improve by using something more smart. That's my first guess of this application. We know that around architecture,
Not so well, but we did not use PostGIS for this study. Everything was done with Python, so we use Rigi, which is a data pipeline builder, which we use scikit-learn for machine learning stuff. We use Folium, which is a library to build some maps, and it's just a way to represent information on maps, but the only database related part of the project was the data storage. No operation was done on data through PostgreSQL or Postgres. It could be possible.
Do you plan to integrate the fact that there are new commerce with new things, where there are no more stations anymore, when you drop your bike wherever you want, which is totally random? And,
Yeah, of course. That's a good question. As you said, this kind of new actor without stations, it generates different results question, and we are out of scopes. Maybe I don't know exactly how it works. If you have a kind of transaction when you drop your bike elsewhere.
in fact, there is lock on the wheel, and with your smartphone, you lock and unlock the wheel.
With a password and okay.
And the thing is, the competition between the various sectors, the stations and those without stations, will be the incentive management.
Okay.
Meaning that people in the world are with the station over there, because here, for example, with your transportation card, you can also use bike.
Yeah.
Which is another company, which is GCDeco, and here this is still NPID. But you can switch from one network to the other, and so the issue will be the incentive management with new players to make you get the bike from the station or get the bike from a random place. And for GCDeco, which is here, this is also nice. Yeah, because
Yeah.
more of this, the thing trying to integrate is that there are plenty of works downtown, which makes their place here, like in Lyon. And before, the guys were coming with their trucks to get back all the bikes and to bring them in the upper
Yeah.
part of the city. And because of the work, it's really hard to make this, and it's delayed. So you have plenty of bikes in the downtown part.
In the same area, yeah.
Huge amount to get them back in the upper part, and the incentive which was before spent on that storage is totally broken by the municipal.
Yeah, it's a different problem because we do not have the station availability question, but you can imagine some it's not really this kind of application, but some sort of traveling salesman problem, maybe, to find a bike which is the nearest bike of you. But yeah, it's definitely a different problem. Yeah, but it could be very interesting to work on.
There is no incentive.
But we have to stop, sorry.
There are incentives. Yeah. Sorry for the.